Okay, this video covers the official AP Calculus 2016 practice exam. We're going to work multiple choice 76 through 90, and if we have some of these will not be covered on the 2020 test, and I'll tell you why when we get to those. So starting at number 76, says to help restore a beach, sand is being added to the beach at a rate of S of t is equal to 65 plus 24 times the sine of 0.3 t tons per hour, where t is measured in hours since 5 a.m. How many tons of sand are added to the beach over the 3-hour period from 7 to 10 a.m.? Okay, so 5 a.m. is times 0. Okay, and so it wants to know from 7 to 10. So from hours 2 to hours 5, right? 5 to 7 is 2, and then 5 to 10 would be 5. So if you want to know the total, you'll just integrate from 2 to 5 of S of t dt, which if you put that in your calculator is 255.368. But this kind of problem is not supposed to be on the 2020 test. So I went ahead. The accumulation of things using integration is not supposed to be on the 2020 test. Okay, so, but still, I wanted to just give you a quick explanation of how to do it. All right, 77. So 77, we have a graph. I'm going to go ahead and put the graph here on the whiteboard. And it says the graph of the function f is shown above. For what values does the limit as x approaches a of f of x equals 0? So remember, this is just asking what is the y value when x approaches. So when is the y value 0? So the limit as x approaches a, your hands have to come together. So at 0, there's a jump discontinuity there. Okay, so the limit from the left is 0, but the limit coming from the right is -1, so the limit doesn't exist. When x is 2, your hands do come together there, all right, for a value of 0. And also when x equals 4, a hole is okay, all right, because it's what does it approach? There's no jump discontinuity there. So it's what is the y value tending towards when the x value approaches 4. And that is going to be 0. So the answer to number 77 is 2 and 4. So that is B. All right, so I definitely think that they could have you read a graph. You know, you'll probably this year potentially have more limit questions since 30% of the material is not going to be on the test, the normal material. Okay, so you could have more limit questions. All right, let's look at 78. 78 says the second derivative of a function, f double prime of x, is equal to sine 3x minus cosine of x squared. All right, how many points of inflection do we have on the interval between 0 and 3? So inflection points occur where f double prime, right, changes signs. Okay, where the second derivative changes signs, goes from negative to positive or positive to negative. So what you want to do is graph this second derivative. And what you're going to get on your calculator between 0 and 3, this is just really roughly what it looks like. Okay, you'll have to zoom in kind of, but it barely, in a couple places, right, it just barely goes above or below the x-axis. It's kind of a mean. So let's say that's 3. So where does f double prime, so this, again, this is a graph of f double prime, where does it change signs? So you can graph this along with me in your calculator. Well, the first time is right here. So that's an inflection point. The second time occurs right here. So that's an inflection point. And then we have one right here, that's a third. One right here, that's a fourth. And one right here is a fifth. So it's 5 times. So the answer is D. So on this year's test, if they ask you like that, you'd have to graph it, count up the number, and then you'd have to write an explanation. And it says inflection points occur where the f double prime changes signs. And you know, you'd have to just write it out like that. Okay, so that's 78. $79. All right, 79, I'll tell you now, not on the 2020 test. Because, and the reason is because it is a velocity, acceleration, position type problem, but you are integrating. No v of t integration, only taking derivatives. But I'm going to still quickly tell you how to do it. So it says, what's the value of 2 to 4 of v of t? And that's a graph of v of t. Well, the value from 2 to 4 is going to be the area under the curve from 2 to 4. And because it's below the x-axis, it's going to be negative. You can eyeball that and see, okay, let's make that a rectangle instead of a parabola there. And you can see that the base would be 2 and the height would be maybe 3. So if you knock off a little bit, -5 is the answer that makes sense. Okay, but one like that should not be on the test. Number 80. All right, number 80. Again, I kind of don't think this one will be on the test, but I'm going to go ahead and explain. I'm not sure, but it says the temperature in a room at midnight is 20 degrees Celsius. Over the next 24 hours, the temperature changes at a rate modeled by the differentiable function h, where h of t is measured in degrees C per hour. Which of the following is the best interpretation? So it says that h of t is equal to degrees Celsius per hour. So it's a rate of change. It'd be like the derivative, a rate of change, degrees Celsius per hour. So if you integrated from 0 to 6 of h of t, it's accumulating. Okay, so it's going to be total degrees C change. You're adding up the total temperature change. Okay, so that is option C. Okay, so think about the units. Degrees C per hour, that's a rate of change. Okay, it said that in the problem description. So if I integrate that, I'm going to go up a level and just get total degrees C. So you can kind of solve it with units, but I kind of don't think one like this will be on the 2020 test. I'm definitely for sure about the last one, but this one, I just kind of don't think it will be. All right, 81. 81, I'm going to pull the problem into view. And so you've got a graph of f prime, and it says, okay, what is a possible graph of the original function? So this is a graph of f prime. So you can see if anytime a graph of the derivative is above the x-axis, that means it's increasing. And then we also have the graph of the derivative above the x-axis here. So for f, the original function f must be increasing from, you know, the left side, negative infinity, to 1 because it's above the x-axis. Because f prime is greater than 0. So which of the answer graphs is that true? Well, A, left to right, remember, is increasing, and then it's increasing to 1, and then it's decreasing. B is out, it's decreasing. C is out, it's decreasing. It's increasing here, but it's decreasing here. And then D is increasing, but from 0 to 1, it's decreasing. So we need a mother graph, okay, up a level from f prime to f that is increasing from the left side all the way to 1, and that is only graph A. So study that one. That's an important one. Okay, so that's an important one to understand. All right, we're moving along. 82. Okay, says let f be a function given by f prime of x is equal to sine x squared minus 3. At what x values between negative 3 and 3 does f have a max? Okay, where's a max? So a max occurs where f prime goes where? From positive to negative. So I want you to graph this on your TI-89. Okay, you're only worried about between negative 3 and 3, so you'll be zooming in kind of on the center of the graph. So graph it. And then if you want, you could hit trace and see where the x values are, where it goes from positive to negative, or you can hit the f5 function and zeros, and you'll have an upper bound and a lower bound that you have to get. Just do that between negative 3 and 3, and what you will get is, it's probably faster just to trace, okay, because you're just eyeballing it, but you'll get that the right answer is option A. So it goes from positive to negative at about negative 1.7, and then also at about 2.4. Okay, so that was option A. So pure calculator type of problem, but you could definitely be doing one like this on the 2020 test. You'll have to write out the answers, though, and not be picking a multiple choice. Okay, number 83, we have a graph. So I'm going to bring that into view. Zoom in if you need to, or just follow along. The graph of the function f is shown above. At what value of x does f have a jump discontinuity? Well, I hope this is obvious. It has a jump discontinuity at x equals 7. Okay? It has a point discontinuity here and here, but here you've got this big gap in the function, so that's a jump discontinuity. All right, so on the 2020 test, you would have to write why you think it's a jump discontinuity. All right, and you would say something like the limit as x approaches 7 from the left does not equal the limit as x approaches 7 from the right. So that's a jump discontinuity. And so it was option C. Okay, but you can see at 3 where there's a hole and at 10 where there's a hole, the limit from the left and the right are equal. Okay, your fingers come together at both of those. All right, if there's a jump, the limits from the left and the right won't be equal. All right, let's look at 84. 84, I do think possibly could be on the test. It says that f of 1 is equal to pi, and f prime of x is equal to the square root of x cubed plus 6. What is the value of f of 5? Okay, so this is how you do it. If you've been given, you want to know what f of 5 is. You haven't been given f, you've been given f prime. This is the fundamental theorem of calculus. Okay, we've worked a few of these, all right, but it's going to be f of 1 plus, so you start here at 1, and then you integrate from that starting point 1 to where you're trying to get to, 5. Okay, from the starting point 1 to 5 of f prime of x dx. That'll give you the area under the curve. You add all that up and then add it to f of 1. So you're going to use your calculator to get this. So we know that f of 1 is pi. And then if you use your calculator, go ahead and give that a try. You're going to get 24.672. So that's 27.814, which is option D. All right, fundamental theorem of calculus. You could see what that is. That's in the realm of possibility for the 2020 test. 85, if you'll read along, people are entering a building at a rate modeled by f of t, and they're leaving at a rate modeled by g of t. The functions f and g are non-negative and differentiable for all times t. Which of the following inequalities indicates that the rate of change of the number of people in the building is increasing? Well, f prime represents a rate of change. In this case, it would be a rate of entry. G prime is a rate of change, in this case, a rate of departure. So if the rate of entry is greater than the rate of departure, you know that the number of people in the building is increasing. So if f prime of t, the rate of entry, let's say the rate of entry in the building is 5 people per minute, and the rate of departure is 4 people per minute, the number of people in the building is going to increase, right? So f prime of t minus g prime of t, if that's greater than 0, then the number of people is going to be increasing, so that's D. If it's less than 0, then the number of people in the building is decreasing. All right, so, you know, it could be one of those. They want you to understand, what does a derivative mean? It's a rate of change, okay? So that's fundamental, so they could ask that on the 2020 test. All right, 86. It says the velocity of a particle moving along the x-axis, v of t, is equal to the square root of t. Let's write that as t to the 1/2 minus cosine e to the t. Which of the following statements is true? Describes the motion of a particle at t equals 1. Okay, so if you look through the answers, the particle moving to the left or the right. So if v of 1, let's just plug that in. So that's 1 to the 1/2 minus the cosine of e to the 1. Put that in your calculator and you'll get that is 1.91. That's positive, so it means it's moving to the right. Now let's see what the acceleration is doing. Well, a of t is equal to v prime of t. So we need to take the derivative of this. That's 1/2 t to the minus 1/2. The derivative of cosine's minus sine, but you've got a negative out front. So that'll be plus sine e to the t times the derivative of the blob, which would be e to the t. So that's 1 over 2 root t plus sine of e to the t times e to the t. Well, acceleration at 1, if we plug 1 into all that, it's all pluses. okay? So we know it's going to be positive. All right, so the answer is B. We have positive acceleration and we have positive velocity, which means to the right. So it's speeding up, which it doesn't ask that, speeding up because velocity and acceleration have the same sign. If they're both the same sign, positive or negative, it's speeding up. All right, I guess I could just say have, same sign. All right, so that's 86. That is a velocity problem where you take a derivative, so that is fair game for the 2020 test. Okay, let's look at 87. Says a tire is leaking air, has an initial air pressure of 30 pounds per square inch. The function T is equal to F of P models the time in hours it takes for air pressure to reach P psi. So it says that F of P, the unit is hours. So what would F prime of P be? It's going to be hours per something, right? It's a rate of change, so hours per something. In this case, it's air pressure, or PSI. So the answer is D. So we've got the unit of the original or father function. Take a derivative, it's going to be a rate, hours per something. That's the derivative, rate of change. So the only option that even works is D. All right, we're moving along well here. Let's look at 88. It says F prime of X is equal to X plus 2 e to the minus X over X squared plus 0.7. We want to know, where is F increasing? This is the derivative. F is increasing, and the reason I keep writing these explanations out is because you're going to have to do that. Where, what? Okay, have you memorized this yet? Okay, I know you got a sheet that's got its on it, but it's where F prime is greater than 0. The easiest place to figure out where F prime is greater than 0, we want to just graph F prime. Okay, and I can tell you, I want you to do that on your TI-89, but if you graph it, the entire graph is above the x-axis. Okay, it does cut off on the left and right side, but the whole thing is above the x-axis, so it's never decreasing. So that eliminates on your answers, it automatically eliminates A, B, and D, because A, B, and D it just has it increasing on certain intervals, or in D's case, it's never increasing. So it rules it out, so it's just C. All right, it says negative infinity to infinity, the thing is increasing. So it goes up to the sky forever. All right, we're almost done. Only 2 more to work in this video. '89. All right, 89, I'm going to go ahead and write out that table because it won't take me long. It'll be easier for you to see. Okay, so it says the table above shows selected values of a continuous function. That's important. There's no breaks or gaps. what is the fewest number of times f of x is equal to 4? Okay, so the fewest number of times it can be is just follow the function, the y value. Okay, we're going from 3 to 4.5. So it has, if it's continuous, it has to cross, it has to hit 4 somewhere. Okay, so there's 1. And then it's going from 4.5 back down to 3. So there's a second time. Now, it could cross it, but it doesn't have to. It goes from 3 down to 2.5, so it doesn't there. But from 2.5, it then goes back up to 4.4, so there's a third time. So if you were to graph this and it be the minimum number of times, right? So let's say this is 3, this is 4, right? When x is 0, it's 3. And then when x is 4, it goes up to 4.5. When x is 6, it goes down to 3. When x is 8, it goes down to 2.5. And when x is 13, it goes up to 4.4, so up here somewhere. All right, so here's 4. So you wouldn't have to do this, you could, but you can see, okay, so let's say it goes doink, doink, doink. So it has to cross it, as long as it's continuous, 3 times. Okay, if you want to know about a theory, what theory does that go with, calculus theory? It's the intermediate value theorem. So if it's continuous, it's got to cross that spot. So on the 2020 test, you probably have to give a theorem, so that'd be the intermediate value theorem. You've got 2 theorems you're probably going to have to deal with, potentially. The mean value theorem and the intermediate value theorem. We've dealt with the mean value theorem a lot of times. Okay, one more. Number 90. All right, so you wouldn't have a problem like number 90 exactly, but the concepts are in play. So it gives you a graph of a derivative, h prime. And it kind of goes like this, and it's going straight up there. Goes like this. Okay, and right here, all right, at 1, you've got a vertical tangent line, okay? So selection 1 says h of -1 has to equal h of 3. Well, remember, this is h prime. It's not h, so h of -1 doesn't have to equal h of 3. So that's a no. Part 2 says h is continuous. Well, it does have a derivative at 1, so if it has a derivative, okay, then since h prime exists, then this is a yes. If h prime exists, then it's going to be continuous at x equals 1. Part 3, it says there's a vertical asymptote. Well, there's a vertical tangent line, but that doesn't mean there's a vertical asymptote. Vertical tangent, so the slope is infinity there, does not necessarily mean a vertical asymptote. Okay, so that's a no. So the only one that's definitely true is 2, which would be answer B. Okay, so that takes care of the multiple choice. Next video, we'll start the free response from this test. And I will, of course, skip the ones that definitely won't be on the 2020. But that video is the one you really want to pay close attention to, since you're going to be doing free response questions on this test, and probably a couple of them. Okay, I will talk to you next video.